In this video, I'd like to talk about breadth first search on a graph data structure. Now, a graph data structure looks something like this, just to refresh our minds. B, C, D. It's a series of nodes and then the edges or connections between them. E. Here's an example graph with a bunch of nodes. And these nodes can represent anything from people and their relationships between each other to positions in a 3D world or a video game that you could traverse between, right? You can imagine each of these are different rooms or different areas in the world that you want your AI to be able to move between. And one of the really common questions that we need to ask about our graph data structures are, from one node, how is it connected to another node? Or is it connected to another node at all, right? These sort of traversal algorithms is exactly what breadth first search is used for. So if you want to pose the question, is A connected to I, right? And how is A connected to I, right? As humans, it's pretty easy for us to look at this thing and say, well, yeah, A is connected to I. You can go down here through G and then H and then I, and there you go. But developing the algorithm that actually searches through this thing is a little bit more tricky than just sort of like looking at this at like a high level. So breadth first search, one of the concepts behind this is that it starts from one node, which is pretty key and pretty important. So in this example here, what I'm talking about is A connected to I. It would start here at node A, right? And the second part about breadth first search is that it's going to explore outward in all directions, right? To do this, the process for breadth first search, it would start here at node A, and it would explore this node. This idea of exploring is essentially asking yourself, what is A connected to? And those are the next nodes that I need to reach out and look at. So when I explore A, the first node, I need to reach out and look at E, G, B, and D, right? So I'm sort of exploring outward in all directions. And now I'm done exploring A. The next node I need to look at are, well, E, G, B, and D. These nodes here that I've explored out from A. So let's look at E. E would say, well, from E, I need to explore F. So it would explore F. And then now I need to look at G, B, and D still, right? Remember, these three haven't gone away, and we want to go out evenly in all directions. So instead of exploring F, because that's the newest node that we've reached, we want to explore G, B, and D next. So let's explore G. Well, G would add H into this list of nodes that we need to explore. And after that, even though H gets us closer to I, we want to explore B and D next because they've been in here the longest, they've been waiting, and they're closest to our original node of A. So next we would explore B. B would add C into this list of nodes that we need to explore. And then finally we'd explore node D. And node D has no new nodes, nothing new that we need to add to it. So we'd eventually get back to exploring node F. This also has no new nodes that we need to add into which nodes we need to explore. And then finally we'd look at node H. And node H would say, hey, look, it's node I, the one that we're looking at, to see if we're actually connected to itself. Or connected, now we can answer this question that, yes, A is connected to I. And we know that because it's connected to I from A, G, H. Now, let's look at the few data structures that we need to be able to implement these algorithms, right? To implement this breadth first search algorithm, we need a few things. The first thing is we need to keep track of which nodes we need to explore next. That's called the frontier. The frontier represents which nodes we still need to explore, right? By default, we are going to add just our start node into it. So we would just add A into the list of nodes that we still need to explore. The next thing that we need to keep track of is this idea of a visited list, right? I'll mark that in green. Visited is going to keep track of which nodes we've already visited. Now, A is the first node we need to explore. It's the very beginning of our question. Like, from A, what can I get to? And can I get to I? And how do I get to I, right? Well, to start, we would add A to our frontier and to our visited lists, right? And then, so A would sort of look like this, but add to our frontier and our visited lists. And then we would explore out from A. A would add E, B, D, and G into both our frontier and our visited lists, right? E, B, D, and G into both our frontier and our visited lists, E, B, D, and G, right? Now we have all these nodes that are inside of our frontier and inside of our visited list. And now, because we've finished exploring A, we would remove it from our frontier data structure. So this is kind of the state of what our frontier and visited would look like, right? A has been removed from our frontier, but we've already visited it, so we're not removing it from that data structure. E, B, D, and G are in both the frontier and our visited lists. So the next thing we do is we take a look. What's the next node we need to explore? We'd ask our frontier, hey frontier, what's the next node we need to explore? Well, of all the nodes that I still have in here, E, B, D, and G, the next one we need to look at is E. It was the first one that you added, so it should be the next one we explore. Let's remove it from the frontier, so it's no longer there. And then we're going to add any of the new connections from E into our frontier and our visited list. The only new one is F. Notice that A is still inside our visited list, which means that we've already been here. We don't want to backtrack. We don't want to go back to A at this point, right? We're exploring outward. So we take a look at F. F needs to be added to our frontier and to our visited list. We add it to our frontier. We add it to our visited list, right? And you can kind of see how these nodes are just exploring outward, right? In the next video, I'm going to talk a little bit more about this frontier and visited list and give you a more concrete example of how we explore from A to I.